Okay, so this video will cover section 2.6, and it will follow some of the information we learned. It's 2.6, 6.2. It will follow the information that we've already learned.
Recording progress.
Let's go ahead and move on. So now we're going to cover some of the theorems of things we learned in section 6.1. One of these is that consecutive angles of a parallelogram are supplementary. What you think about consecutive angles, let me move this out of the way, maybe. Okay. So our consecutive angles, like this side and this side, those meet to make an angle here, and then the next angle that follows it is over here. So these two angles together are consecutive, therefore they are supplementary, which means that their sum, when you add them together, it equals 180 degrees. This makes sense, right? Because if you take those left and right sides and you kind of pull them up, hinge them up, they would make a straight line. It is simply that that fourth side that you can't bend outward. So any consecutive angles are going to be supplementary. So if you know one, you can subtract that amount, that measurement from 180 to find the other. Also, we know that opposite angles, so in opposite corners, these are, let's see, opposite are congruent, which makes sense, right? Because if this angle and this angle are supplementary and opposite angles, and then that second one there where I've got the two lines, that one is also supplementary to its next consecutive angle, then those two opposite sides must be the same measurement because both of them are the difference of 180 minus this angle right here. So they've got to be congruent. That also means that these two sides are going to be congruent to each other as well. All right. A corollary of that is if a parallelogram has one right angle, then it has to have four right angles and therefore is a rectangle. Excuse me. So try to do this. So if I have one right angle, well, I know that its opposite is congruent, therefore that one is a right angle. And I know that its consecutive is 180 minus 90, which is 90. So that one has to be 90 degrees. And its opposite must be congruent. And so that's how you end up with all four 90-degree angles. And then your parallelogram becomes a rectangle. All right, moving on. Opposite sides of a parallelogram are also congruent. So if you bisect your parallelogram, like they've done here with the dotted blue line, what you've done is you've created two triangles. And then you know that because these lines are parallel, that if this is the transversal, then its alternate interior angles are going to be congruent. So you've got congruent angles, and then that side is also congruent. So you can prove that those two triangles that are made by that bisector are going to be congruent triangles. Therefore, their corresponding parts are congruent. So these sides are congruent, and then the third side is congruent as well. So that's how we are able to prove, clean that up a little bit, prove that opposite sides of a parallelogram, they will always be congruent to each other because they're parallel lines, and we can use our parallel line postulates and theorems to help prove that the interior angles are congruent, which therefore, and the share side makes the two triangles congruent, and then its corresponding parts. Okay, let's move on to the next one. So the diagonals of a parallelogram bisect each other. So this means that if we have, again, we create diagonals are bisectors of those angles. So again, you're creating congruent angles inside with these bisectors that therefore make their lines congruent within these triangles. And so therefore, you know that where they intersect is also creating congruent sides. So that is a midpoint of both diagonals. Now, you can see if I named this, say, E, A to E is congruent to C to E, but it is not necessarily congruent to the other sides of the other diagonal. Like BE is not necessarily congruent to AE, but it is congruent to DE, its other, the other half of that same diagonal. All right, so let's look about at how we can use this information to, just make sure I'm recording here, to determine the length of sides and the measurements of angles. All right, so in this one, it's asking us to find each measure in ABCD if line segment BD equals 11.6 meters and angle, the measurement of angle ABC is 72. All right, so this first one, we're just working with the line segments. Excuse me. So they tell us that our entire diagonal, it's really big, has a measurement of, let's see, BD is 11.6 meters. So if I needed to find DC, well, that's going to use information that they already gave me here. I know that DC is congruent to AB because they're opposite sides. So, so for our first one here, we can say that DC, oops, the measurement of DC equals the measurement of AB, which equals 6.3 meters. And so that is the measurement of DC as well. Excuse me. The second one here, EC. So EC is the other diagonal. They've told us that half of it is 4.2 meters. So AE, let's say EC is equal to AE because that's a bisector. So we know that these two sides are congruent, and AE is equal to 4.2 meters. Therefore, EC is 4.2 meters. All right, and our last one, C, is asking the length of ED. So that's this guy right here. ED is going to be half of that entire diagonal BD. So ED equals 1/2 of B. Ooh, my internet's acting up. BD. So it's 1/2 of 11.6. And let's see, 2 goes into 11 5 times, carry my 1. 2 goes into 16 8 times, so 5.8 meters is the length of both ED and BE. So there's my length of ED. All right, let's go ahead and move on to the angles. So if we look at the angles, they told us that measurement of angle ABC is 72. So that's this entire angle is 72 degrees. Let's make that legible. And I also know that half of this right here, ABE, is 41 degrees. So I can use that to find the other half. I also know that this one here is going to match ADC, is going to also be 72 degrees. And then BCD, that entire side, is 180 minus 72, which is 108. Probably what they're going to ask us to find, but I'm just going to go ahead and break it all down using the theorems that we just learned. So that one is also 108 because it's opposite to angle C. All right, so the measurement of angle DAB, DAB, we just determined is 108. So the measurement of angle DAB is equal to 180 minus 72. My internet makes my pen wonky. All right, so DAB is 108 degrees. ADC is the opposite to angle ABC. So that means the measurement of angle ADC is equal to 72 degrees because it's opposite of what was given. And then the last one, DAC, we also know measurement of angle DAC is 108 as well. So I broke it down. And then we can also find all of these interior ones. Let me just make sure. D A. Oh, I didn't, did I? Hold on. DAC is this one. All right, so that angle. So again, let's look at this. So this, we know this side and this side, these are parallel lines if we extended them because of parallelogram. And then this is the transversal. So if you'll notice, we can look at alternate interior angles. So 63, if that angle is 63, and I'm so sorry, this is so messy. See if I can make that transversal just a little neater. There we go. All right, 63 degrees here. Therefore, over here is also 63 degrees. And we know that the sum of, oh goodness, sorry. The sum of both of these added together is 108. So DAC is actually 108 minus 63, which is that opposite side. So that gives us 5, 10 to the base 4. So the measurement angle DAC is 45 degrees. It's the difference of 108, which is that entire angle BAD, minus that sort of top left side that's 63 degrees. So we're even going back to using our rules from our parallel section in previous chapters. Okay. Are there more? There are more. Okay, the measurement. Okay, the measurement of DAB. Okay, that's this whole guy here, which we already determined earlier is 108 degrees because it's 180 minus 72. ADC is where? ADC. Okay, that's this whole one here. So that is, wait, is this the same? Oh, that's right. I think this is the one that I apologize. I think I like duplicated a slide. ADC, DAC. I did. Sorry. Disregard that. It's a repeat. Let's go ahead and move to example 2. Okay, so here we're finding the measure of each angle and side in our parallelogram JKLM. Excuse me. All right, so we're going to start off on this one. I'm going to start off and go ahead and find the angles. So this slide's going to cover angles. The next slide is just a repeat. We'll do the math for sides. I'm trying to make sure I give you guys plenty of room. Okay, so they gave us angle J is 7A degrees and angle M is 13A degrees. So these two are consecutive. Consecutive angles are supplementary. So we can go ahead and write our equation for either one. Let's go ahead and find A first. So our first step is we have to find our variable. So 7A plus 13A equals 180 degrees. Go ahead and combine this. I get 20A equals 180. They were so kind to make the numbers nice and even. And so A equals 9. All right, not 9 degrees. That's just our variable. The second one, we got to plug that in. So 7A is, 7 times 9, which is 63 degrees. That is the measurement of angle J. And also that's the measurement of its opposite, angle L. So measurement of angle J and angle L is 63 degrees. I'm going to go ahead. The other one, we could also plug in 9, do 13 times 9. However, just to kind of practice this whole supplementary thing, if J is 63 degrees, then M, 13A, is 180. So the measurement of angle M is 180 minus 63, which gives me, is 117, 10 to the power 3, 7, yeah. So that's 117 degrees. And because that's angle M, it's also the measurement of angle K. So the measurement of angle M and the measurement of angle K is 117 degrees. If you plug that in, 13 times 9 is also 117 degrees. Either way, give you the same answer. All right, so let's move on to the angles now, or excuse me, the side lengths. Now we know that these two sides are congruent, and we know that these two sides are also congruent. However, we've got two different variables, so we have to somewhat use the system of equations. We'll use substitution. So I know that x equals 2y, come on, so messy, plus 1. And so that's my jk and my ml. And then jm is 2x equals 5y minus 2. So I can take this value for x that has y and plug that into my x right here. So 2 times 2y plus 1 equals 5y minus 2. And then solve for y. Once I have y, I can either just, well, we'll get to that in a second. Let's go ahead and do the math. 4y plus 2 equals 5y minus 2. All right, I'm moving this 4y over, so I keep things positive. So 2 equals y minus 2. I'm going to add 2 to both sides, and I get y equals 4. All right, so once I know that y equals 4, I'm going to plug that in to ML. We do it at either one, either ML or KL. I'm going to do ML. So ML is 2y plus 1. So that's 2 times 4 plus 1. So that means that ML equals 9. So length of 9. And then if ML equals 9, that means that JK also equals 9. So JK, which equals X, also equals 9. So that means that X equals 9. Now, if we plug that in, excuse me, plug that into JM, got these two here. So because JK is X and it equals 9, I now know that X equals 9 because JK equals 9. So I'm going to plug that into JM. JM equals 2 times X, excuse me, 2X. Let's just do baby steps here, which means that's 2 times 9. So JM equals 18. And if JM equals 18, KL also equals 18 because those are opposite sides, therefore they are congruent, therefore their lengths are exactly the same. Now, say you plugged in y for KL. 5 times 4 is 20 minus 2 is 18. So you get the same answer no matter which one you do first, but you've got to find one of your variables, use that to find the value of the other, and then just distribute that information around to find all the different sides. That is pretty much it. The only other thing, I didn't actually get a chance to talk about this in class, but I'll go ahead and put it in our, put it here in the video. So if 3 or more parallel lines divide a transversal into congruent segments, then they divide every other transversal into congruent segments as well. So what this is saying is we have our 3 parallel lines, A, B, and C, and they are dividing the transversal S so that each of these, so these two, oh, that's quite all right. You can see how they've marked this. These two segments, JK and KL, are both congruent. That also means that your, what are those? Consecutive exterior angles. I don't remember right now. Angle 3 and angle 4 are also congruent, and angle the top right here on point J, that's also going to be congruent to those other two interior angles. They divide every other transversal into congruent segments. So again, these two are also going to be congruent because that's a different transversal, but those are the same 3 parallel lines, and therefore it proves additional congruency. That is it. We are actually going to do the homework in class tomorrow for practice. We might have to finish it for homework just so you guys can get some practice on your own to make sure you're ready for what we do on the quiz. But for now, This is it for section 6.5, and I will see you guys in class tomorrow. Thanks.